then we're going to use properties of definite integrals given certain information here. For example, we're given the integrals with sine of x. All of these are sine of x. And this one equals a, this one equals b, and this one equals c, depending on what your upper and lower limits are. And then we are to do 4 examples. So we have 1, 2, 3, 4, using the properties of definite integrals to make it look like one of these up here. It's basically a practice of using properties of definite integrals. So I have some written here. These are the ones that we don't use all the time. They occasionally come up, but not all the time. So it's I just included the ones that that we don't use all the time. So for the first one, we have the integral from a to a. This one is pretty easy. The lower and upper limits are the same, and when they're the same, you get 0. So it doesn't matter whatever your f of x is. In our case, it's sine of x. It's going to be 0. So that one was easy. We'll check this one off. Let's do the next one. The next one, we have the integral from b to a of sine of x dx. According to the information we're given, with b and a in it, it's this one. This one has the b and the a in it. This one says, and I know it's kind of small, so I'm going to rewrite it. This is from a to b, sine of x dx. And this equals a. And you notice how our limits are flipped around here. So basically using property 2, I can reverse my limits here by putting a negative in front. I can rewrite it this way and put this right. The upper limit is b, the lower limit is a. So we have sine of x dx. All right, well this part here we already know equals a because it's given, but we have this negative in front, so our answer is negative a. All right, so there's that one. Let's do number 3. We have the integral from a to c of sine of x dx. All right, now let's see what we have, c to a. The only thing we have c to a is this one. So what I'm going to do is use both of these to go from c to a. So we have the a and the c here. That's called the additive property for definite integrals. So what I can do is rewrite this using this property. So I can go from b to a, sine of x dx, and then plus c to b, sine of x dx. My handwriting's gotten bad. All right. So notice that these b's, the b's that are missing from this one, are right here. So the c is still your upper limit and your a is your lower limit. So just kind of get used to that a little bit. But we already know that this equals a and this one here equals b. So your answer is a plus b. So again, this is just practice. Now the last one, it's dealing with this one. So let's write that out. We're almost done. We have this integral here given. So I'm going to write this as the integral from a to c. And I'll write it out again in case you can't see it. Sine of x plus 2 sine of x plus pi divided by 4 dx. All right, so I can write this as from c to a, sine of x dx, and split it up, plus 2 times the integral from a to c of sine of x plus pi divided by 4 dx. Okay, so from the previous slide, we already did this one. Remember, this was a plus b. And then this one here, it's given. I don't know if you can see that, but this is straight from our formula here. This equals c, but we have this 2 in front. So this is going to be plus 2c. And this is your final answer. And again, this was just practice using our properties of definite integrals. I have this on my Facebook page. If you ever, or any of my videos, if you want to save a photo, you can just go to my Facebook page and save it from there. Because I know they're hard to see on the video sometime. Thank you. Have a nice day. Bye-bye.